We're infusing machine learning and AI into many aspects of ArcGIS. This morning, I want to show you two new tools that we've built that have machine learning at their heart. And this stuff is not rocket science. We've made it really approachable right inside of simple geoprocessing tools. So let's jump to Pittsburgh, where we want to site a new retail store. We're looking for clusters of restaurants where people are likely to stroll or linger, popping into a restaurant for a bite to eat, a coffee shop for a cup of coffee, and doing some shopping along the way. We'll use the new density-based clustering tool to help us automatically find these clusters. Now, what's so exciting about a machine learning method like density-based clustering is that it discovers the clusters for us. All we have to do is tell it what we consider a cluster. In this case, at least 10 restaurants, and it does the rest. Goes through the data, evaluating the distances between points, and before I can even explain how it works, it's found those natural clusters in the data. Here, those points that have been colored are part of different clusters, and those that are in gray have been marked as noise. Now, the power of having machine learning tools like this inside of ArcGIS is that it means that they fit into our workflows and they're easily accessible. So in this case, we might continue our workflow by delineating neighborhoods around each of those clusters using ellipses and enriching them with data from ArcGIS Online so that we can look at things like total retail sales to help us prioritize sites. Now, the other new tool that we've just released is based on the very powerful machine learning algorithm called random forest, which is used in a wide range of prediction applications. Today, I want to show you an example looking at childhood asthma hospitalization rates in Connecticut. Now, the data is only available at the census tract level, and like with a lot of public health data, we're missing some. So we want to use the new forest-based classification and regression tool to help us train a model to predict asthma hospitalization rates at the block group level, which will allow us to fill in those missing values with empty values, with estimated values. So we have a bunch of variables that we think will help our prediction. Socioeconomic and behavioral variables like income, smoking, and expenditure on insurance, as well as environmental factors that are related to asthma, like road density, distance from air-emitted toxic releases, and air quality, just to name a few. Now, to train our forest, which is where we teach the algorithm using the data that we have, all we have to do is point to that combination of attributes and rasters and let the tool go to work. Behind the scenes, the algorithm is creating a series of decision trees that get intelligently fused into a powerful forest that is surprisingly good at training accurate models. And we don't need to know how decision trees work, or a forest for that matter. It just does it, and we made it really easy. Now, there's a lot of diagnostics that we can use to evaluate our model, including an R-squared, which in this case is 0.86. So we're predicting with 86% accuracy. The tool also produces a chart, which gives us a sense of how important each of those variables was in our model. So in this case, we can see that those socioeconomic and behavioral variables are up at the top. But our environmental factors, those more spatial variables, are still playing a critical role in our prediction. Now that we have a model, we can use it to predict asthma rates at the block group by simply changing the mode of the tool to predict to features, pointing to our block groups, and the tool will automatically apply that trained model to our block groups and produce a prediction for each feature. So immediately we can see that we filled in the holes of missing data all over Connecticut, and we've produced much more detailed spatial data. And we can do so much with this tool. Everything from predicting crop yield. We can do a lot more than this. We can predict crop yield, we can estimate home values, we can classify tree cover. Really, the possibilities are endless. And these new tools are just an example of the way that we're infusing ArcGIS with machine learning and AI. in ways that'll help you immediately take advantage of these evolving methods to solve the critical problems that you face, taking the next step.